In this video, we will review hearing instrument test box measures, as well as how to perform those measures within the Medrex Studio software. Before you begin testing using the HIT box, you should calibrate the coupler response. First, carefully install the coupler microphone. The white arrow should be facing the front of the box. Next, place the coupler microphone between 2 and 8 millimeters from the reference microphone. You should raise the coupler microphone to the same level as the reference microphone by using the large O-ring that was included in the kit. In the Medrex Studio software, you want to click on the HIT module. To calibrate the coupler response, click on the down arrow next to Precalibrate and click OK. The Precalibrate function allows you to calibrate the reference level without the hearing aid turned on and then run the test without referencing. Precalibrate can be used if it is suspected that a high gain hearing aid is leaking sound, thus affecting the reference microphone. HIT box verification can be completed by clicking on the 3 dots on the top of the screen. Click on the check mark to open up the verification screen. If all 4 verification test results are green, then you can continue and begin using the HIT box. If any of the tests are red, please check the reference microphone placement in the HIT box and repeat verification. Please view our user manual or training videos on our website for instructions on how to attach ITE, RIC, and BTE hearing aids in the HIT box. If performing a battery current test, make sure to insert the appropriate battery pill into the hearing aid prior to the start of testing. After coupler calibration and test box verification are complete, connect the hearing instrument to the manufacturer's fitting software. The hearing instrument will stay connected inside of the test chamber if a wireless connection was used. If wired, the wires or the loop can be placed inside of the test chamber to maintain connection to the fitting software. When coupling the hearing instrument in the test chamber, make sure to place the hearing aid microphone within 2 to 8 millimeters from the reference microphone, and that it is also at the same height as the reference microphone. In the software, you can choose to run each measurement test individually or in a sequence through our auto test feature. If completing each test individually, click on the test name and then click on the Start button. Make sure to change the hearing aid settings from full-on gain to reference test gain according to what test you are completing at the time. The hearing aid should be in full-on gain mode when completing the OSPL 90 and full-on gain measurements. The hearing aid should be in reference test gain when completing the reference test gain, frequency response, harmonic distortion, equivalent noise input, input-output, attack release, battery current, or induction coil measurements. In order to use the auto test feature, you must select each test that you want to run by clicking on the red X by the test name, and it will change to a green checkbox when you have added it to your auto test sequence. After selecting the test you would like to complete, click on the Start Auto button. With the hearing aid in full-on gain mode, the OSPL 90 is a measurement of the hearing instrument's maximum sound pressure level at each frequency using a 90 dB SPL pure tone sweep. Full-on gain is a measurement of the hearing instrument's gain using a 50 or a 60 dB SPL pure tone sweep. The gain of the hearing instrument is the difference between the measure output SPL and the input SPL. Once the OSPL90 and full-on gain tests are complete, the software will prompt you to adjust the hearing aid settings to reference test gain before moving on to the next test. The frequency response is a measure of the hearing instrument's frequency response to the desired input level. This test can be run with an input level between 50 and 100 dB SPL. Harmonic distortion is a measure of the degree of harmonic distortion of a hearing instrument. Distortion typically occurs when the hearing instrument is working at its upper capacity limit, or if the signal is limited or clipped, as in the hearing instrument has peak clipping circuits. Equivalent input noise is a measure of the internal noise generated by the hearing instrument. For the input-output, this is a measurement that is producing a graph showing the relationship between input sound pressure level and output sound pressure level. This measurement is made for one frequency at a time. It is useful for nonlinear, wide dynamic range hearing instruments or instruments with automatic gain control, as it is used to determine and adjust the knee point of the compression circuit or the automatic gain control. It can be used with linear instruments to determine the level at which saturation starts to occur. Attack release. The purpose of this task is to measure the dynamic characteristics of the compression circuit or the automatic gain control in the hearing instrument. The display shows a grid with time in milliseconds on the horizontal axis and dBSPL on the vertical axis. Attack time is measured as the time between an abrupt signal stimulus level increase and the point where the hearing instrument output signal has stabilized to within 3 dB of the steady value for the high input sound pressure level. Release time is measured as the time between the abrupt drop from 80 dB to 55 dB and the point where the hearing instrument signal has stabilized to within 3 dB of the steady state value for the 55 dB input sound pressure level. Battery current. This task is used to measure the current draw from the battery by the hearing instrument. A battery simulator is built into the system to provide a power supply to the hearing instrument and to measure the current draw by the hearing instrument. The battery pill in the test chamber is inserted into the hearing aid and is attached to the system by a cable to the simulator. Induction coil. This task checks if the hearing instrument induction coil meets the specifications stated by the manufacturer. Although the ANSI standard only requires a measure at 1000 Hz, this system performs a whole curve to provide more information. During the test, the hearing instrument should be oriented for maximum pickup sensitivity. This depends on the orientation of the induction coil inside of the hearing instrument. It may be useful to measure a number of curves with different orientations of the hearing instrument.